In this video, we're going to solve quadratic inequalities by using graphing, and then we're going to solve a system of quadratic inequalities by also using graphing. Now, while graphing a quadratic inequality might sound a little bit complicated, it's actually very similar to graphing a quadratic equation. It just has a couple of additional steps added on to the end. So we're actually going to start and just assume this is an equation, and we're going to calculate the points that we need to create an accurate graph here. So what I notice here is that here I have a quadratic because it has an x squared, and I notice that it's written in standard form. So I'm going to start by finding the axis of symmetry, which is going to be x is equal to opposite b, so -4, over 2 times a, which is -1. So we have -4 over -2, which gives us a positive 2. So the vertex has an x value of 2. And then we're going to pick a couple of points around it. So let's do like 1, 0, and -1, and then maybe let's do 3, 4, and 5. So let's start by calculating some of these points. So here if we start with y, and remember I'm going to assume this is an equal sign for right now. We'll come back to the fact that it's an inequality later. So we have y equals, it's a negative, and then I have -1 in parentheses squared, plus 4 times -1 minus 2. Well, this turns into 1 squared, so it's a negative times 1 squared, which is -1 plus, this becomes -4 minus 2, which that altogether becomes -7. So this -1 is -7, as is the 5 on the outside. Then if we move to 0, we have y equals negative, then we have 0 squared plus 4 times 0 minus 2. Well, that becomes 0 plus 0 minus 2, which is a -2. And then here we have y equals a negative times 1 squared plus 4 times 1 minus 2. Well, that becomes -1 plus 4 minus 2, which becomes just 1. And then finally we have y equals a negative, here we have 2 squared plus 4 times 2 minus 2, which gives me -4 plus 8 minus 2, which is a positive 2. So just by using some basic algebra here, I can calculate my points. Now what I'm going to do next is I'm going to plot these. So I have x is -1, y is -7, 0, -2, 1, 1, 2, 2, 3, 1, 4, -2, and the last one is 5, -7. So up until this point, this has been identical to graphing a quadratic equation. Now, there are two differences here. So the first difference that we need to note is that when we have an inequality, we're either going to have a dotted line or a solid line. And the dotted line is used when we do not have the equal to underneath. And what that communicates to the person viewing our graph is that the points on the line itself do not make this inequality true because they are the equal to part, and we don't have the equal to part of that inequality. We then use a solid line if we have the equal to part underneath, because that communicates that the points that are directly on that line do in fact make that inequality true because it has the equal to. So because this does not have an equal to underneath here, what we're going to do is we're going to graph it by utilizing a dotted line. So you'll notice I'm leaving some spaces in between to signify the dotted line. Then from here, the second difference is that this is going to have shading, because when you have an inequality, you have an entire set of values that make this inequality true. And so we need to be able to represent all of the possible values since there's more than a couple of answers. So what we need to do is we need to pick a point. And what you'll notice here is we have two different regions. We have the region inside of the parabola, and we have this entire region out here that is outside of the parabola. So I have region 1, and then I have region 2 here on the outside. And what I need to do is I need to determine which region I need to shade. So typically what you can do is you can pick one point on the graph. So let's say here that I'm going to pick this point right here. So I'm going to pick the point x is 2, y is 0. And it doesn't matter which point you pick. It just matters that you pick a point somewhere on the coordinate plane that is not on the actual dotted or solid line there. So what I'm going to do here is I'm going to test this point. inside of this inequality. And if this point works, I'm going to shade where that point is. And if that point doesn't work in the inequality, I'm going to shade the other region. So here I have y is greater than negative x squared plus 4x minus 2. So if I'm using this point, I have 0 is greater than negative, and then I have 2 squared plus 4 times 2 minus 2. Well, negative times 2 squared is negative 4 plus 8 minus 2. So this turns into the inequality of 0 is greater than 2. And what I notice here is that 0 is not greater than 2, and this is a false statement. And what this tells me is that this point that I picked, 2, 0, does not make the inequality true. So because it doesn't make the inequality true, all of these points inside of here do not work in this inequality. But what this also tells me is that all of the points outside of here do work in the inequality. So if I picked any of these points on the outside here, they would make this original inequality true. So as you can see, this is very similar to graphing the equations. It just has 2 additional steps of thinking through what type of line you're going to use, dotted or solid, and then finding which direction you are going to shade. So now I'm going to apply the same type of thinking to a system of quadratic inequalities. And I'm going to just graph them one at a time. So there's inequality number 1, there is inequality number 2, and the only difference when dealing with a system is we're going to graph both on the same coordinate plane, and we're going to look for the area that is double shaded. And essentially that double shaded area is going to make both inequalities true. So let's start with inequality number 1. And what I notice when I look at inequality number 1 is that I have something written in vertex form. So my vertex is going to be at x is negative 4, y is negative 3. So I'm going to put that into the middle of my table. And then I'm going to calculate some points around it. Now you can either calculate these by hand or use a calculator. It does not matter to me. But if we start with x is negative 1. So if we start with that, remember we're going to pretend this is an equation for a second. We have 2 times negative 1 plus 4 quantity squared minus 3. Well, this here is going to turn into 3 squared, so that's 9. 9 times 2 is 18, so 18 minus 3 is 15. Then if I move in, I have y equals 2 times negative 2 plus 4 quantity squared minus 3. Well, this part right here turns into 2 squared, which is 4. 4 times 2 is 8, and 8 minus 3 is 5. Then if I look at the next one, y equals 2 times negative 3 plus 4 minus 3, and then that parentheses part is squared. Well, negative 3 plus 4 is 1, so that 1 squared, and then times 2 is 2 minus 3, so that gives me a negative 1. So now I have some points for my graph. So if I plot my vertex first, I have 4, negative 3, and then I go up to negative 1 around that, then I go up to 5. And then that next point of 15 is off of the graph, so I'm going to leave that as is. I'm not going to try to graph that. Now, I'm going to erase my work here just to give myself a little bit more room. But what I'm going to do now is I'm going to now treat this as the inequality that it is, and I'm going to make some decisions. First, I need to decide if I'm going to have a dotted line or a solid line, and because this has the equal to underneath it, I know that I'm going to use a solid line here. So I can go ahead and draw this. And then from here, I have to determine which direction I'm going to shade. And remember, we determine that by picking an arbitrary point on the coordinate plane that is not on the line. And we determine whether or not that point works in this inequality. And if it does, we shade that direction. And if it doesn't, we shade the other direction. So for this particular one, I'm just going to choose the point x is negative 4 and y is 0. So from here, I'm going to plug that point into this inequality. So I have y is greater than or equal to 2x plus 4 quantity squared minus 3. So I'm substituting my values in. So 0 greater than 2 times negative 4 plus 4 minus 3. Don't forget your squared. So this is 0 is greater than or equal to, well, this turns into 0. 0 squared is 0. 0 times 2 is 0. Minus 3 would be a negative 3. So what I notice here is I have something that says 0 is greater than or equal to negative 3. And this is true. So because of this, I'm going to shade in that particular region, because this particular region contains a point that works in my inequality, and that tells me that all of the points in this particular region work in inequality number 1. So we've now graphed our first one. So now let's move on and let's look at the second example and plot this on the same coordinate plane. So I'm going to make a table of values here as well. This one is written in standard form, so I need to use the axis of symmetry trick. So axis of symmetry is x equals negative b over 2 times a. So it's opposite b, so it becomes a positive 6 over 2 times negative 1. So if I simplify that, we get 6 over negative 2, which is negative 3. So my vertex point for the second graph is occurring at negative 3. And then I'm going to find some additional points around that. So I'll have to calculate these by hand. So we have y, and remember we're going to pretend this is an equation temporarily. So y equals negative, we have 0 squared minus 6 times 0 minus 6. Well, that turns into 0 minus 0 minus 6, which is a negative 6. I then go to y equals negative 1 squared minus 6 times negative 1, so I'm going to use keep, change there so I don't make a mistake, minus 6. Well, negative 1 squared is 1, and tack the negative on, that's a negative 1. Negative 6 times negative 1 is a positive 6. Then minus 6, that becomes a negative 1. So then I have y equals negative 2 squared plus negative 6 times negative 2 minus 6. So that becomes negative 2 squared is 4 times the negative out in front is negative 4 plus negative 6 times negative 2 is 12 minus 6. So that gives me 2. And then finally our vertex y equals negative 3 squared plus a negative 6 times negative 3, then minus 6. So that becomes negative 3 squared is 9 times the negative out in front is negative 9 plus negative 3 times negative 6 is a positive 18, and then minus 6. So that turns into negative 9 plus 18 is 9, minus 6 more is 3. So now I can plot these points. So I go to x is negative 3, y is 1, 2, 3. I then go to negative 4, 2, and negative 2, 2, negative 5, negative 1, negative 1, negative 1, and then 0, negative 6, and negative 6, negative 6. Then from here, I need to decide if I have a dotted line or a solid line. And if I look at my inequality, I notice that it doesn't have an equal to. So this is going to have a dotted line. So I can draw that in there. And then lastly, we need to decide which way to shade this inequality. And so we need to pick a point somewhere on the coordinate plane that's not on that blue line. So I'm just going to pick this point here of negative 3, 0. And I'm going to see if the point that I picked works inside of this inequality or not. And that will determine if I shade towards that point or if I shade away from that point. So I have y is less than negative x squared minus 6x minus 6. So we have 0 is less than negative 3 squared plus negative 6 times negative 3 minus 6. So we have 0 is less than, this becomes 9. With the negative, it's a negative 9 plus, that's a positive 18, minus 6. So this becomes 0 is less than, well, negative 9 plus 18 is 9, minus 6 more is 3. And what I notice here is that 0 is less than 3 is a true statement. So what that tells me is I'm going to shade towards that point inside of that blue parabola. So I'm going to shade right inside of here. So we've now graphed both of these individually, and what we're looking for is the double shaded area. And when I look at this situation, what I notice is there's a little double shaded area right here. So I like to make this area darker and more obvious. But this double shaded area here, what it actually represents is it represents all of the points that make both of these quadratic inequalities true. So this little black region right here, all of the points there make both of these quadratic inequalities true.